we have harder materials like tooth itself, dentine, enamel, or denture framework, or even porcelain, which is the hardest material. So depending on the application, we can range material from soft material to hard material. So hardness is an indicative of material processing. If material is very hard, we cannot cut it. It is very difficult to make scratches, to make polishing and finishing. For example, denture material, if it is very hard, it is difficult to cut and finish for the technician. On the other hand, if material is very soft, it can be easily scratched. For example, if denture is very soft, patient can brush it with hard bristle and make it damage with scratches. So these scratches can lead to failure because these scratches are potential area of weakness. And when a material is subject to various scratches, it can lead to failure of material. So we have to adjust the hardness of our material depending on application. Similarly, natural teeth, we know natural teeth are very hard, but if any material that is harder than natural teeth, it will damage natural teeth. For example, porcelain. It is very hard material. It is harder than natural tooth enamel. So as a result, it might damage natural tooth enamel. Similarly, scratching soft materials, for example, impression material or dye material, which are softer material, we should keep in mind the scratching them might damage the accuracy because they are soft material, they can easily be damaged. In terms of very hard materials such as cobalt chrome material, they are very hard and difficult to finish because they are hard material and not easy to cut and finish them. Now the question arises, simply saying this is a hard material, this is a soft material is not enough. We have to have some quantitative criteria to measure the hardness. We should know the hardness quantitatively with numbers like this is hard material or what is hardness of this material. So we have various techniques or various methods to measure the hardness of dental materials. We will discuss commonly used methods, and you should not be worried about the names because names are new to you. Brinell method, Knoop, Vickers, Rockwell, and Shora hardness test. So these are various tests which we use for the measurement of hardness. I would like to say the principle of measuring hardness is the same. How we measure the hardness, we press a simple indenter into a material. And then we see the size of the indent, like the size of the penetration into the material. If material is soft, we will get a big area or big size of indentation, which suggests us material is soft. However, if material is hard, we will get a very little size of indentation. So these all materials work on the same method. But what is the difference? So now we will focus on the difference. The difference is in terms of indenter material size and testing method. Let's discuss these methods one by one. First of all, it comes the Brinell hardness testing method, which is the oldest method used for testing material. So you can see in this image, we have a round ball shape indenter and we press it against the surface. Once we press it against the surface, and hold it for a few seconds and then move it back. So what we get? We get a hole or depression like this, which we call indentation. Now we calculate the hardness of a material depending on the size of this or area of this indentation. If this indentation is big, this means material is soft. If this indentation is small, this means material is hard. So typically we use a steel ball or tungsten carbide ball with a specific load, which we hold it for 30 seconds, let's say, and then remove the load, and then we measure the area. So this is how it looks like. If the indentation is big size, soft material, indentation is small size, hard material. And this is microscopic view of indentation. Because sometimes indent is not visible with naked eye. So we have to see with microscope, and we calculate the area using microscope. So this is simple formula which we apply, load, the force we apply on the surface, and then area of the indentation, and we calculate Brinell hardness number. So this gives us Brinell hardness number, which is higher means hard material. If it is lower, then it means soft material. So the smaller area of indentation, the harder the material. So this rule will continue for all the methods. If the indentation is smaller, material is hard. If indentation is large, material is soft. So this will apply on all the methods. The problem with this method is the ball size is very big. So we cannot use this method for brittle materials or elastic materials. Because in case of brittle materials, due to blunt ball size, it will fracture the material. And if material is resilient like rubber or elastomers, it will recover, it will remove indentation, and we cannot measure the area of indentation in case of rubber materials. So this is the shortcoming of this method. We cannot use it for most of dental materials and even tooth structure because they are brittle. Once we try to test these materials with Brinell method, they will get cracked or fractured, which means we cannot get estimation of actual hardness. And in resilient material, we will lose the indent size. We cannot measure the area of indentation size. So therefore, we need more methods to measure the hardness. For example, Knoop and Vickers hardness testing methods. Both are similar methods. They work on the same principle. Only difference is the indenter shape. In Knoop hardness, we use a diamond with pyramid shape. So as a result, we apply load and we get a pyramid shape of indentation. We don't get a round shape of indentation. And we calculate the area. Once we remove the indent, we calculate the area of this indent to calculate the hardness. So what we see here, the indenter shape is different. It is not a round ball. It is a pyramid shape. Similarly, correspondingly, we get a different shape of indent also. And rest of the method is same. We apply force and load is applied to the area of indentation, and unit is Knoop hardness number, which suggests we are using Knoop method, and the unit is kilogram per millimeter square. How much weight we applied in kilogram and the area of indentation in millimeter square. This method can be used for harder materials. Because of shape of indenter, it will not cause fracture of brittle material. So we can use that for brittle material. We can use that for harder materials like metals, alloys, we can use this method. Also, why I go back on this slide to show you the indenter is diamond. So diamond is the hardest material. There is no other material that is harder than diamond. So diamond can indent any material. Therefore, we can use it for harder materials. Previously in Brinell method, we used steel ball, which is not as hard as diamond. Due to the shape of indenter, new method has been used extensively for various dental materials, including metals and alloys, enamel and dentine itself. Okay, so what is the disadvantage of this method? Because indenter is very fine shape, we cannot test a material that has rough surface. We need highly polished surface, and it may take a long time because we need proper sample preparation for this method. The Vickers method is not very different from no hardness method, only there is difference in shape. We still use the diamond in indenter. Indenter is made of diamond. Only the shape is different. We use square-based pyramid here. And still we can apply load in kilograms, and indenter we get a square shape, not the pyramid shape. So here is schematic presentation. If you see, this is cross section, and the square shape indenter will indent the surface. And then once we remove, we get a square shape indentation. This is shown microscopically because indent may be too small to be visible with microscope. Now we calculate the area of this indent to find out the hardness of material. Same principle, if indent is big, material is soft. If this indent area is small, this means material is very hard. And we express it by Vickers hardness number because we apply the same formula, load divided by surface area of the indent. And we express it by V.H.N, which means the hardness number is calculated with the help of Vickers method. The features are similar to Noop. We can use it for hard material. We can use it for tooth structure and dental materials. However, not suitable for elastic recovery materials or viscoelastic materials. Because once we remove indent from the surface, the material will recover quickly. We cannot measure the area of surface to calculate the hardness. So to make it clear, I have put this slide for you. If you see the Brinell method, round ball we used, Noop we used pyramid shape or parallelogram shape, and Vickers we used square shape. And these are the indent size. Of course, we will get round shape in Brinell, but this is just schematic to show the size. If the size is large, soft material. As we reduce the size of indent, material is hard. So this is the principle how we calculate hardness of these materials. But now the question is, any of these methods cannot be used for viscoelastic material like rubber or soft materials which have elastic recovery. So how we calculate, or how can we calculate hardness of such materials? So there are few methods for such materials. For example, Rockwell hardness test, and the next one also I will explain for such materials. What we understand from Rockwell hardness test method? It is a rapid method because we don't need to calculate the area of these materials. So how this works, instead of measuring the diameter of the indentation, the depth is measured directly by a sensitive dial meter. That is why we are using this method for elastic recovery materials, because we don't need to measure the indentation size. We have attached meter which can calculate directly the hardness of material. Doesn't matter, it recover the indentation point. However, we have to apply weight twice because this method works on a different principle. The material is elastic, so we apply a very light load, which is called minor load, or sometimes it is termed preload. In this preload, the indenter will simply touch the surface and apply a very minor load, like for example, 3 kilogram. And then this step is just to make sure the indenter is touching the surface. Once we are sure it is touching the surface, we apply another major load, which can range up to 30 kilogram. And once we apply major load, we hold it for a few minutes, not seconds, because this is for elastic materials, and the indentation will be supplemented by a meter which can directly tell us about the hardness of the material. As it says, measured by micrometer, which is coming with this measurement system, and we don't need to calculate the area of indentation. We directly can calculate the hardness. It is simply scaled in digits, and it can give us hardness from 0 to above number like around 150, because the rubber or elastic materials are not very hard. So it can simply tell us from 0 to around 105 or 1010, increasing with hardness. However, this is not suitable for brittle material. It is only suitable for elastic recovery materials or viscoelastic materials. And the main advantage is we don't need to calculate the area. It directly tells us about hardness of elastic and viscoelastic materials. It needs preload, which means it needs more time, more technique sensitivity. We have to apply a preload. We have to make sure the indenter touch the surface, and then we make a second load application to measure the hardness of material. Another similar method is show a hardness tester. This comes with a meter or scale which is called durometer, which is scaled from 0 to 100. So how this works, again, this system comes with a indenter which can penetrate into rubber materials. And this durometer, it tells us reading from 0 to 100. So 0 means the full penetration and material is soft. However, if there is no penetration, it will read 100 and give us hard material. So this range from 0 to 100. So 0, sorry, I think I have explained it in reverse section. 0 means no penetration, because meter will stay at 0. And if we touch on the surface, no penetration, it will read 0, which means it's hard surface. However, if soft surface like rubbers, it will fully penetrate and will give us a reading of 100. We can use this method for soft liner, mouth protectors, and elastomeric materials like impression materials, this kind of. And other advantages, it gives us immediate reading what is hardness of elastic materials. Of course, we cannot use it for very hard materials or brittle materials, because it will not give us a correct reading. Another test is Barkol hardness test, which is used for composite materials for depth of cure. So we simply can understand the surface of material is hard and it is cured from the inside or not. So it tells us depth of cure. If it is fully cured, it should be hard from surface and inside as well. So it comes up with a spring loaded needle with a diameter of 1 millimeter, and that is pressed against the surface of composite material. As shown in this image, it is pressed against the surface of material. And if there is no penetration, the scale will read 100, similar to Shore durameter test. And if there is full penetration, it means material is soft and it will read as 100. So no penetration, it will read 100. And if there is full penetration, which is a soft material, it will read 0. Right. So to avoid any confusion, I have put this slide. So on this one slide, you can compare all methods, which I have explained, because they work on similar principle. There is only difference between the force application, indenter shape, and indenter characteristics. For example, Brinell hardness test. So this slide gives you a revision and good overview about all the hardness testing methods. Brinell test, we use round steel ball or tungsten carbide ball, diameter 1.6 millimeter, which is a big diameter for brittle material. And we press it with force for 30 seconds and then remove it and measure the size of indent. Larger size, soft material, smaller size, hard material. Move to noob hardness test in detail. We apply a force in kilograms and get area measured in millimeter square. And extremely delicate micro indentation are produced, which are measured by microscopic evaluation. We need sample preparation and smooth surface for this method. Wicker hardness test, similar method, only we use different shape of indenter. We used square shape and we get square indent that can be measured on the same principle. And then we have Rockwell hardness test for elastic materials, where we apply preload and we measure directly with the help of meter. There is no need to measure the area. And then we have Shore hardness test used for elastomers and viscoelastic material, blunt and indenter of 0.8 to 1.6 millimeter can penetrate the surface. 0 means full penetration or soft material, and 100 means 0 penetration and hard material. So this scale shows an estimated measurement of various materials which we use everyday life, and it tells and gives us an idea hardness of various soft rubber-like materials. So remember, this test can only be used for elastic materials, viscoelastic materials, rubbers, and this kind of materials. In dentistry, we can use for example, impression materials. Right. We come to micro hardness. Basically, we test micro hardness even for Vickers and noob hardness test, because sometimes indent is too small and we cannot measure the area with naked eye, or we can measure but not accurately. So therefore, we need testing micro hardness where we can calculate and visibility of the indentation using a microscope. In that case, we can use low force, like up to 2 Newton, and indentation will be small because force is low, and we can calculate using a microscope. The latest equipment, they are produced where software have been developed and they automatically magnify the indent shape and size and calculate the area for us and hardness. So this is not difficult. Similarly, nano indentation is a concept because traditional indentation produced a large indent that might damage the surface as well, because the indent size might range from 100 micron or even to millimeters for softer materials. So if we are using the same specimen or same sample for any other testing, the normal hardness testing might damage the surface. So therefore, nano indentation may be helpful. Otherwise, our materials are mostly composite. So which means they are mixture. We will teach you composite materials in the next term. So composite are the materials which are mixture of more than one materials, like filler particles, matrix. So they might have a different hardness in different phases. For example, filler has different hardness, matrix or polymer has different hardness. So we can use nano indentation for measuring such materials. These techniques, commonly referred as nano indentation, are able to apply a very minor load in milligrams, and resultant indentation will also be very small. So 1 micron, obviously we cannot see 1 micron with the help of eye. So we need microscopic evaluation. And these equipments for nano indentation, they come with the magnifying camera. So they show us the size of indentation magnified. So 1 micron will be magnified, which we can see in the software. And the software calculate the area of this micron size indent and ultimate hardness as well. I know this is a big topic. I explained to you briefly to give you a concept, and also regarding all materials, if you like to have further reading, I will suggest this book chapter. If anyone interested to read it further in detail, you can click on this link and find this chapter to read further. So I hope everyone is clear about surface mechanical properties, mainly hardness, various methods of measuring hardness, and you understand what is importance of surface hardness and how we need to measure it.
Doctor,
Yes.
what's the importance of indentation in dentistry?
Okay. The indentation is not important for dentistry. It is important for measuring hardness. We need to understand indentation for measuring hardness, and hardness is important for dentistry, because for every application we need uh, various hardness materials. For certain application, for example, impression or questions.
Yes, the elastic material, we cannot use it for the first three devices. We cannot measure it by the first three devices.
No, no, no. Because first three devices, they will make an indent. They will make you can say a surface hole. Okay, and then once we remove that indenter, we measure the area of that indent. So what is problem in elastic materials? Once we remove the
Cover
indent, once we remove the force, the indent will finish. It will recover due to elasticity of the materials. So therefore, we cannot use first three materials for elastic materials. No. Any other question? Okay.
Doctor,
Yes. Yes.
a letter in Rockwell. Um,
Yeah.
what is this for?
Okay. The Rockwell can be used for thin sheets for elastic materials also. However, from the Rockwell, we start measuring with a meter. We don't need to measure the area of indentation. We simply, the system comes up with a small meter. And once we apply force on the material surface, the meter will tell us hardness of the material, how hard it is the material, without calculation of surface area of indent. However, we need to apply force 2 times. First time we touch the surface and apply very light force, which usually we call preload. So this is like if there is any stress in the material or any, for example, bubble on the surface or something like that, to recover that and to make sure the indent is touching the surface. Now we apply another force to calculate the hardness. So this is slightly different principle for Rockwell.
Doctor, can you please repeat about dentition?
Okay, indentation. Well, this now the problem is like this is a virtual classroom. If I have a physical classroom, I show that indentation with the help of a pen. If you have a pen and you press it against the paper, you will see a small tiny dot. So this is indentation. So once you press a needle against any surface, you will see a small tiny depression. So this is called indentation. Now, if you take a needle or paper pin or thumb pin and you press it against a wood or a table, you will get a small tiny hole. So this is indentation. But if you press the same pin against butter, for example, you will get a big hole. So this means butter is a soft material and wood is a hard material. I hope it is clear to you now.
Doctor,
Yes.
in Rockwell, why we in slide number 22,
Yeah.
it said viscoelastic material good for, why it's good for it?
Why it is good for elastic materials, you mean? It is good for elastic materials because elastic materials, they recover quickly from the indentation. For example, if we press elastic material with a finger, and if we remove finger, it will come back to the same shape. So this means first 3 methods we cannot use for elastic materials, because once we remove the indenter, the material will come back to its previous shape. The benefit in Rockwell, it measures with the meter. So it immediately tells us hardness of the material. So this is why it is suitable for elastic material. And also we can use show a hardness test as well. So, but the only difference, Rockwell we can use for harder material also. Like for example, if some rubber is very hard, for example, but sure, a hardness test may be for softer materials, like for very soft rubbers or impression materials, something like that. Yes, any other question?
Doctor,
Yes.
did you record the lecture?
The previous lecture is recorded and I will see the file. If it's saved properly, I will send you. I will share with you. I will share with the leader and he can share with everyone.
Okay, thank you.
Yeah. I'm happy you are asking questions, which shows me you are picking up. Alhamdulillah, you are understanding the concept. And then let me explain you, like you cannot catch or pick up 100% from the lecture. You have to read it after all. So any other question? Okay, thank you very much, everyone.
Doctor?
I will, yes.
Do we have to memorize the
Yeah, this is
kilogram of the loads used in each test.
right. This is very common question, and student ask me from every batch. So every batch they ask me these numbers are important. Do we need to memorize? I would say yes. If you can, yes, why not? But these numbers sometimes are put to give you an idea.
So we have to understand the big picture of this number.
Yeah, if you can memorize, this is good. Like because it might avoid you from misleading. For example, if I say, okay, shore hardness is 110. So you should have idea. Shore hardness cannot be more than 100. Shore scale is 0 to 100. So how come hardness can be 110? It cannot be. So it give you an idea. Like if I say, okay, dentine hardness is 280 KHN. So you should understand if some material is 300, it is harder than dentine. But the exact number is no problem. You can just read it, but you should have an idea about it.
Okay, thank you.
Thank you. Thank you very much. I will share the recorded lecture if I can find the file from recording, inshallah.